goes under different purification process. Then after, finally, they will release this active chlorine directly to kill microorganisms. So if these microorganisms will affect our human organisms drastically, so for that case we need to kill these microorganisms. For that case we will use this bleaching powder for the domestic purpose, to clean bathrooms and also to purify water in our syntax water. So if that water, if still we will feel that still there are some microorganisms will contaminate our water, so we need to add some bleaching powder into the water. So over there in calcium oxychloride will separate or liberates chlorine, and the chlorine kill microorganisms. Okay. Today we will estimate percentage of chlorine present in bleaching powder. Okay. So this is also very similar experiment like estimation of copper by iodometry. Estimation of copper by iodometry. This experiment is also same like that experiment. Here also we will use potassium iodide starch. Okay, starch as an indicator, potassium iodide as an reagent. Okay. So this experiment is also of 3 procedures or 3 steps. First one is standardization of potassium dichromate, as that we have discussed how to standardize potassium dichromate. Here over the 0.125 grams. Okay, 0.125 grams dissolved in 100 ml of distilled water in a standard flask. Okay, but I am not keeping it here. That is already I have shown you in experiment 2. So if you want, you can see in experiment 2 that you will find that experiment procedure, how that I have done that experiment. Okay. And in second step, standardization of hypo. Okay, standardization of hypo by using 20 ml of potassium dichromate and 20 ml of sulfuric acid, then 10 ml of potassium iodide and 1 ml of starch that we have added, and the color of the solution from dark brown to light green color. Okay, light green color, that is our endpoint, standardization of hypo. Already that we have done in our previous experiment. That two steps for this experiment is also same. So for that case, the final step, estimation of active chlorine in bleaching powder. Okay, estimation of active chlorine in bleaching powder. That step I am going to show you. Okay. In first of all, we need to take 10 ml of bleaching powder, which is already 1 gram of bleaching powder dissolved in 100 ml of distilled water. Okay, already our lab assistant has prepared that 1 gram and dissolved in 100 ml, and into that 10 ml of that bleaching powder I have taken into standard flask. For that I have make up with the distilled water. By using distilled water I have make up until this point. Okay, so this is the colorless solution. So this is the lower meniscus that we will take. So here this is the bleaching powder that means which is contains active chlorine content present into this solution. Okay, from this we need to take almost 10 ml. From this we need to take 10 ml of this solution into conical flask, a clean conical flask. Already I have cleaned this conical flask. Okay, so we will add then after 10 ml of potassium iodide. Okay, 10 ml of potassium iodide and almost 10 ml of acetic acid, dilute acetic acid we need to add. Then it is a hypo, we need to pour it into burette. Okay, this is the burette, 50 ml burette. We need to pour this hypo. This is sodium thiosulfate. Pour it into burette. Okay, so then after, from this pipette, 20 ml pipette, we need to take this solution. Okay, so the solution into conical flask. Okay, so I think this is no need right now. We need to use measuring jars. To estimate acetic acid and bleaching powder. And this is the starch solution. Okay, already prepared by our lab assistant. This is 2 ml we will add it into conical flask. Just like in the same experiment, estimation of copper, this is also estimation of active chlorine in presented bleaching powder. Okay. So remaining of all the explanation part, I will explain you during our laboratory session, virtual laboratory session. I will show you in the form of a PDF copy. Today evening, before the evening, I will post that experiment 3 PDF copy and also this video also. Okay. Students, I am going to start this experiment. We need to take a 10 ml of bleaching powder solution. Okay, 10 ml of bleaching powder solution. Okay, 10 ml of bleaching powder solution I have taken and I have poured into 1 cup flask. Okay. Then after 10 ml of potassium iodide. Sorry, for 5 ml of potassium iodide we need to add. Then after 10 ml of dilute acetic acid. And 2 ml of starch solution. 2 ml of starch solution. I am going to add approximately. I don't have a proper measuring cylinder, so I am adding approximately to this solution. Okay. So this is the reagent solution. Okay, we are going to titrate against hypo. Okay, this is the reagent solution. We are going to titrate against hypo. So we need to fill this hypo solution into burette. Okay, first of all we need to rinse this burette with hypo. Okay, already I have rinsed this burette with hypo. So directly I am going to take hypo solution into burette. Take excess amount and there is some this point need to be filled with hypo. So I am going to discard this excess of the solution to the sink and make it the point until up to the 0. Okay. So then we need to start our experiment. This color of the solution, while we are titrating, the color of the solution is turned into blue color. Then we need to add excess of the hypo to disappear that blue color solution into colorless. Okay, that is our end point. Okay? Next we will start this titration. Okay, this is our reagent solution. We are going to titrate against sodium thiosulfate, which is hypo. Okay. So always you need to keep your left 3 fingers on the knob of burette and try to add hypo drop by drop and titrate, and from your right hand onwards you need to shake your conical flask slowly. Okay, gently. That need to be the reaction will be started slowly. Okay students, I think after completion of the reaction, it will at 2 ml the complete color of the solution is disappeared and it will become colorless solution. Okay. So we need to calculate with this end point, okay, which is a 2 ml. 2 or 3. 2 ml, 2.5 ml. Okay, it's almost 2.5 ml. We need to take this 2.5 ml as our end point, and we need to calculate to estimation of active chlorine present in bleaching powder. Okay. So after we can find the normality of the solution, we need to find the percentage. Here it is written. Here the normality of active chlorine that we are going to find present in bleaching powder. So this is the formula entry into gram equivalent weight, which is 35.5 into 100 by 1000. Then we need to find percentage of chlorine. Okay, percentage of chlorine is equals to amount of the chlorine divided by weight of the calcium chloride, which we have taken to make it this solution before 1 gram in 100 ml. So 1 gram. So amount of the chlorine is that we need to find. Okay, so then into 100, then we can find percentage of the chlorine. Okay, so we need to apply this formula to find percentage of the chlorine. Okay, so okay, students, just think about how I have done this experiment and how I have mixed upon the solution in different ratio. That means 10 ml of this potassium iodide is 5 ml, and 10 ml of acetic acid and 10 ml of bleaching powder solution. Then I have added 2 ml of the starch. Okay, so I have taken approximately, but for your experiment you need to take in measuring cylinder 2 ml. Okay, so then you need to start your experiment against hypo with you need to this reagent you need to react with hypo solution. Then here also same, this potassium iodide react with calcium oxychloride with bleaching powder. Then it will become potassium chloride and active iodine will be liberated, and the liberated iodine react with the sodium thiosulfate and it will become sodium thionate. Okay, sodium thionate after completion of the reaction. Okay. So this is the experiment how to find estimation of active chlorine present in calcium oxychloride or bleaching powder. So that's it.